Before we start, I have exactly two questions for you. The first one would be, who of you is using PayPal? Please raise your hands. Don't be shy. Okay, who's using the PayPal app? Okay, that's a new one. 0. Don't be sad if you haven't raised your hands. Normally, you could have looked for the last people who raised their hands, and because this is going to come in handy later, but I guess you're all lucky then. Imagine you're at a conference, sitting in the audience, like you do. The audience is a bit large, it's like 4,000 people. It's a keynote. You see like 20 apps on the screen. They get narrowed down to 2 apps. And you might already guess from my title, it's probably not going to be about who did the best UX design. It's about security. And I'm sitting in this audience, and it's one of the apps I worked for at a client. And there might be some things you think about at that very moment. Shit is probably one of them. But the thing is, you couldn't really have done anything else, or you couldn't really have done more. And why is that? That's we're going to take a look on in this talk. So I think we don't really have to motivate security itself. There was a lot happening in the last year or so. I don't really sure I could update the slide again, but I think we know that security is important. There are a lot of examples where you might be losing some money, and that's why I think we should talk a little bit about it. You might saw the title. It's a bit clickbaity, isn't it? Yeah, I don't really like clickbait titles, especially like on YouTube, where it's like, you all know it. But why did I pick the title? We're going to take a look into these hyped hacks, so to speak. And I thought, if you want to acquire some money, it would be nice to have an escape car first, wouldn't it? Like, if you're going to rob a bank, you probably need a nice, fast car. So let's take a look at this first hack.
The security of the internet-connected devices that we use in our daily lives heavily depends on the apps used to access, monitor, and control the devices.
I will show an easy way how you can obtain the username and password that a Tesla owner is using to log into the Tesla app and use that to control his car. The methods we use for this are really simple, and they have been known for years and have been also used by cyber criminals for a long time. What I've done now is I've created a free Wi-Fi hotspot that displays an advertisement that's targeted towards Tesla owners that says that if you install this free app, you can get a free burger at the restaurant close by. So I can see now here Lars has logged into my Wi-Fi hotspot. What happened now is that Lars was tricked to install an app on his phone. The app installed malware on his phone, and that malware is manipulating the Tesla app on his device, so that when Lars logs into the app, it will send his username and password to me. So now here I can see where he actually is, and let's just wait and see where he's parking. If I was really a criminal, I would have done this not during the day, walking around with a big laptop, but I would probably use a small phone or something. But this is just a demonstration, right? Let's see, I think it should be over there. Okay, there you see, that's the car. Let's see what we can do with it. You know, the last thing I have to be able to drive the car without having the key. That's also possible. The keyless driving is enabled, which means we can just drive off with the car. Let's try. And that's how easy it was. We have full...
Okay, I guess thanks Lars, now we have our car. if you paid a little bit attention, you probably also you already have some foreshadowing about what happened there. But before we're going to go into it, yeah, let's continue. I mean, now we have our car. I think we are ready to go for the banks, aren't we? Okay, I brought you another one, but this time I'm going to have to do the talking because it's in German, so I'm going to be your translator. Basically, what you're seeing is it's the largest German bank, and the app is from 2015. So what he's showing you is basically the app is up to date, and he's going to make a bank transfer. He's going to open the transfer dialog, enter some details because he's paying his university library fees of €3, and so he's entering all the details and he's confirming, and then the 10 number is going to be sent over the second app to factor authentication on the same device. That's a different topic. You see, okay, €3. He's also showing you, obviously, that this is also the newest version back at the time. And you see, okay, the receiver is correct. You see the amount, €3 is correct. You get the 10, and then he confirms it. Okay, the transfer is done, everything good and fine. Now he's going to go into the turnovers, and surprise, surprise, it's not €3 but 4.20. The numbers joke aside. We see, okay, I mean, he modified the amount what was actually sent. So that's already nice, but I think we want to make some money, so it's, I think, like just changing some values is not going to help us here. So I was working at my former client on a banking app, but the thing is, because of NDAs, obviously I can't really show you what I did. So I thought, yeah, let's pick something where you can all relate. So I was looking around at the Play Store, like what app has some downloads, and let's just take a look into it. I came to this app and I thought, yeah, like 1 or 2 people downloaded it, so I could check it out. And I mean, at least I'm also using PayPal, so that's at least one motivation as well. So yeah, to cut things short, I also have I have a demo, but I'm going to do it by video because things always don't work out if you try to do live demos, especially if mobile. And also there's another reason, because the PayPal app prevents you from recording your screen, and you can circumvent that, but then let's put it like this: it's more work to do the demo itself than to actually like circumvent the recording thingy. Okay, so that's my app and my work, so to speak. And as I'm obviously a pro hacker, I'm not only going to show you that I've installed the newest version from the Play Store. Oh, it's a bit darker on that screen. I hope you can still see it. But you see, when I did the demo, it was the newest version. And I have €1 whole on the account because my mom always said, don't play with money. So we keep it small. And you can also see at the bottom that it's actually installed from the Play Store and that it's not something modified. Okay, let's make a bank transfer or PayPal transfer in that account. I'm going to send some money to the Doctors Without Borders. A huge amount, because I don't want to send all my money. It's only 33 cents. And yeah, you select the funding. Okay. You get to see the details again. The amount is correct. The receiver is correct. And it confirms me again. But you already see on the refresh, the money didn't really go to Doctors Without Borders, but yeah, to a different address, in that case to me. So, well, in that case my money belongs to me, I guess, but yeah, you get the idea. And you could also see it obviously on the web interface. So, but side note, I actually donated some money to Doctors Without Borders later on, so don't worry. Okay, now that you have seen all the 3 hacks, you might think, yeah, that looks really bad, doesn't it? At least from the first look of it. The thing is, it isn't really that bad, but we come into, at least from a technical part, but we're going to look into that now. So, what did happen here? Well, as the previous hack and my hack, what happened, we modified basically values during runtime. I mean, it's not a big deal. I took a bit the easier route. I just used the code injection framework, so I don't have to like write a whole exploit myself. I just went into like modifying the actual values, saves a bit of time. But one thing which everything more or less like has in common is, well, the device was compromised. You might remember from the very first video where the user was supposed to switch to the Wi-Fi, download what was it? I think free burgers or free Wi-Fi. No, you already have the Wi-Fi, but the free burgers app. Yeah, that's more or less where you compromise the device. And from the second video, also there was some. Well, you didn't see it specifically there, but what was in the video before, also the device got compromised. So, well, so how did I do it like on a more grand scale? Well, I had the idea, I want to modify the values. So I first have to get an understanding like how does the app actually work. For that, you can just decompile the app. And yeah, you try to get an understanding how does the app work and where could I modify my values. If you're not familiar with the Android environment in that case, just a short roundup. If you're using Java, you probably know, okay, you have your source code, you compile it to Java bytecode, and then it gets run by the JVM. It's pretty similar with Android, just that you have like double the process. And so you also compile it to Java bytecode, then there's a DEX compiler, and in the end it gets run by the Dalvik JVM, or RT nowadays. What's interesting to know is that we have pretty good Java bytecode decompilers, so you more or less can read pretty precisely what was written before and get an understanding of what's happened there. And we also have quite good DEX to Java bytecode converters or decompilers. So yeah, that's an easy approach there. And but that's more or less what I did. I took a look into the paper lab and started searching, sending money, send money, because eventually I want to modify the values at the pretty bottom of the whole layers. So ideally speaking, I only want to modify the network packages, but that is actually more work, so I started basically just one layer above it. And I found this very nice method, send money. I think that's good enough for us. The only thing I had to figure out is like, okay, what are the parameters standing for? I mean, there's one called address, which I thought at first, okay, that's it, perfect, just going to modify that. It's actually the address where the shipping information is like. When you pay something with PayPal, you always have this like shipping to. Yeah, that's the address field. The actual receiver is behind the str for string. I think they could do some refactoring there. Would be nice. Yeah, so you just have to modify the value. You basically inject and do a before hook, and then you modify the value. And that's more or less it for making your stuff run. So how are you going to deal with it? The first question is like what's the probability And the probability to like someone doing just what I did is actually rather high because it's really easy. You just have to get an understanding of like how the runtime injection frameworks works, what do you have to modify, and then you can do that in, well, I did this on one weekend to just get the demo running. So you can do it too without too much prior experience in developing mobile apps. The other question is risk impact. So how big is the impact in that case? I mean, if you get the device compromised, you have compromised this one user. For sure, you don't want to have like some money going from your user account to a different account, but like in grand scheme kind of things, it's somewhat limited. And also, at least I don't know how it is here, but in Germany, like most of the banks have some like limit for you as a customer. Like if you do online banking or something similar, they're more or less like going to pay if something fucks up. I mean, as a business perspective, that's still something you have to deal with, but you also have like the fraud prevention frameworks, which also PayPal has. So it's going to pick up on it and going to block the transactions after a while. The other question is how scalable is this hack? I mean, coming from, okay, you have to compromise the device, it's not going to be a widespread problem, at least in the sense of, yeah, you're not going to have root access to all the devices. But the thing is, I included this very nice quadrant because it's like the default thing consultants do, and I don't really like it, but just for the joke of it. We already talked about the likelihood, and the other part is the consequence. I mean, the likelihood is high, we talked about it. The consequence from a technical perspective, I would say, is rather low. But the thing is, if your app gets showcased in a keynote at a security conference, and it's going to be in the newspaper the next day, I think you have a different kind of consequence because you're going to speak about your brand, your product, and the image of your product. So there's still some consequence you're going to have to deal with. The only thing is, how you're going to explain it. Yeah, that's more or less like the problem. So what can you do beforehand? Do what we did. We basically sat down and took a look at our app and said, okay, what are potential attack vectors? What could happen? And how could we deal with it? Like, also speak with colleagues, just brainstorm. You're going to come up with quite some stuff, to be honest. If you don't feel comfortable, just get external knowledge, and there are companies who do security consulting. They're going to help you, and with all that input, you can try to prepare your PR and marketing department. So you can already think about, okay, what can we respond if like a hack like this is going to show up, even though like the technical impact is like what you can do to make it harder. We're going to talk in a second about it, but it's not that you're going to have to as a developer, like you already did your dues beforehand. So it's only like, okay, if something like that comes up, that's what we can communicate to our customers. And the last part, making it harder to understand and modify your app, because there are tools for it. And to be honest, I don't really know why PayPal makes it so easy. And at that point, that's like, if somebody knows, like, feel free. What I would suggest, like from a developer's perspective, is try to take a look into like the available tools. So you have like static analyzers. I'm just going to name one example for each, so you have an idea where to look into. And there are very nice tools out there which can help you. One thing I really like is the OWASP dependency analyzer. which basically analyzes all the dependencies you have in your app. If you're using Gradle in that case, in combination with Android, you get a very nice report. There are the code obfuscation tools. Android comes with ProGuard, which helps you to really like obfuscate your code, make it harder to understand what's actually happening in your app. And there are also security frameworks out there which work in runtime. Some of them also supply you with different APIs. For example, if you're making a web request, then they support you with certificate pinning, where it makes others harder to get an understanding what traffic are you exchanging with the backend. There are some of them I listed here is like DexGuard, Promon we saw in the very first video. I don't really like their marketing. I don't know why. But at least their product works. And there's also Neosec and others. So to give you an idea how the different things looks like, this is the OWASP dependency analyzer. I hope you can recognize a bit. What it basically does, it scans all your libraries and gives you different, more or less like, I'm not sure if you can see. So you see like, okay, it scanned like 80 dependencies and it found like 18 which are vulnerable. And you get a listing of each of them and also like their severity. And if you select one of them, you can see, for example, the individual CVEs which are affected. And the best course of action is obviously try to update your dependencies. And you can also configure it so it's when it's part of your build pipeline, if it reaches a certain threshold that your build fails, and then you pay a bit more attention to it. Because I mean, sure, you can just like save the report and that's it, which happens too often. But the idea is to really do some action about it. I mean, if you put in your definition of done, for example, that helps as well. And for the code obfuscation, just to get the idea, it's basically you have your normal classes and methods. In that case, like action, bar, draw, toggle, delegate, provider, which gets translated to A, B, if you also use the package names, and that's basically what's happening. So all your variables, your methods, and class names get translated to indistinguishable letters. So you only see like, okay, A is doing something with B, and you don't really know what's in it. And that already makes it way harder to get an understanding like what somebody needs to modify in your app. Okay. Yeah, and the last one is like a lot of the security frameworks provide you basically with like a drop-in solution. So you use your final artifact from your release build, put it in there, they're going to wrap it up. Basically what most of the time happens for Android, for example, they use your DEX files and encrypt them, and they get decrypted in memory during runtime. That's like one of the features they have. And also they supply you, as I said, with different kind of APIs you can use for encryption and so on to make it harder for someone to analyze your application. That's it so far from my side. And